You know the story, right? It's probably one of the most incredible narratives in all of science. The origin story of, well, everything. Right. So, that's the Big Bang model, pretty much in a nutshell. It's the absolute bedrock of modern cosmology. The idea that our entire universe, all of space, all of time, all of us, it all began at a single, super hot, super dense point. It's elegant, it's powerful, and wow, is it backed by a mountain of evidence. But here's the thing. What if that whole story, as compelling as it is, starts with a question we never even thought to ask?
I mean, what if the very concept of a beginning is just us, a human assumption we've projected onto the cosmos? Now, to really get why that is such a wild thought, we've got to first appreciate just how powerful the story we all know so well really is. Okay, let's be clear. We absolutely cannot overstate how successful the Big Bang model is. This isn't just some random guess, it's a full-blown theory that has made some just stunningly accurate predictions about the universe we see all around us. I'm talking about things like the cosmic microwave background, that's the faint leftover heat from that initial hot state, and it's still visible in every single direction we look. Or, the way galaxies are all clustered together in these vast cosmic webs. And of course, the big one, the fact that distant galaxies are all flying away from us, their light getting stretched out into the red end of the spectrum. It all seems to point back to a single explosive origin. And here's the crucial point. All of this evidence, it's fantastic support for the idea that the universe was once a lot hotter and a lot denser. But does it require an absolute beginning from nothing? Now that's the leap we really need to take a closer look at. You see, the standard model runs into a major, major problem when we try to rewind the cosmic clock all the way back. Our physics, our math, they just completely break down. We hit something called the singularity. Now, it's often described as the point from which the universe popped into existence, but it's not really a physical place or a moment we've ever observed. It's more like a mathematical warning sign. And this really gets to a core idea in physics. Whenever your equations spit out an infinity, it usually doesn't mean you found something infinitely dense or infinitely hot. It's a huge red flag that your theory has been pushed way past its limits, and you need a new, deeper understanding. So this leads us to the really critical question. Is the singularity the actual beginning of everything, or is it just the point where our current knowledge completely falls apart? Are we mistaking the edge of our equations for the edge of reality itself? Okay, so with that question hanging in the air, let's go back to that key evidence for the Big Bang. Could we be reading it a different way? Take the CMB. Its incredible uniformity across the sky is usually seen as Exhibit A for a common origin. But what if it's evidence of something else entirely? What if it's a sign that the universe has had an immense, maybe even infinite amount of time to just settle down and reach a stable, uniform temperature? This is a really key shift in perspective. Think about it. A hot cup of coffee you leave in a room eventually becomes the same temperature as the room. That uniformity, that equilibrium, it doesn't tell you when the coffee was poured, it just tells you it's been sitting there for a while. What if the universe is just like that? And what about that redshift of galaxies? We see them moving apart and we say, aha, space is expanding. But maybe, just maybe, we're seeing something else. A continuous, huge-scale process where the universe is simply rearranging itself, kind of changing its internal structure without ever needing to have grown from a single point. And this, of course, leads us to the biggest, most mind-bending question of all, one that really challenges our most basic intuition, the nature of time itself. In modern physics, time isn't some universal clock just ticking away in the background. Time is the process of change. If nothing changes, time literally has no meaning. So asking what happened before the universe, it might be like asking what's north of the North Pole. The question itself might just not make any sense. Here's an analogy. A river flows without ever needing to remember where its first drop of water came from. The process of flowing is its reality. Well, maybe the universe is just the same. A continuous, unending flow of change with no first moment. Okay. But there's a huge scientific objection here, and it's a fair one. The laws of thermodynamics, right? They say that over time, everything tends toward disorder, towards heat death. So if the universe is eternal, shouldn't it have completely run down by now? Well, the universe isn't just a simple, sealed-off box. Within that overall trend toward disorder, amazing pockets of incredible order can, and obviously do, form.
I mean, stars, galaxies, life itself, these are all fantastic examples of local order just popping up. So maybe the cosmos isn't on a one-way trip to chaos. Maybe it's in a constant dynamic cycle of reconfiguration, of creation and dissolution.
So where does all of this leave us? It actually offers a really profound new way to look at absolutely everything. This is the fundamental choice we're looking at. Is the universe a product that was created once, an event that we're all just living in the aftermath of? Or is it an ongoing condition, a process that is continuously unfolding with no beginning and maybe no end? It's a huge shift from thinking of the universe as a thing that happened to a thing that is happening right now. And the real beauty of this alternative view is that it kind of lets science off the hook from trying to answer a possibly unanswerable metaphysical question about creation from nothing. Instead, it lets physics focus on what physics does best, describing the processes and the transformations that we can actually observe and test. And that's really the final thought to leave you with. This whole idea isn't about disproving the Big Bang, not at all. It's about questioning one of its deepest, most fundamental assumptions. It's a quiet little challenge that doesn't close the door on cosmology, but instead, it blows it wide open to a whole new universe of possibilities. What if the most profound truth about the cosmos is that it simply